Hello students, continuing from the previous video, next one we have is the spiral model. It was suggested by Boehm and it combines the development activities with the risk management to minimize and control risks. So it's a kind of a detailed model, and it's also an important one, and all these models are important. Students, you need to know this. And this model is represented as a spiral in which each iteration is represented. Actually, spiral model is a kind of iteration model, and it's represented by a circuit around four major activities like plan, determine goals, alternatives and constraints, and evaluate alternatives and risk, develop and test. So this is how it looks like. And see, this each quadrant has its own set, like it starts from here. So here it is determine objectives, alternatives and constraints for the project to start with. Then see, in the previous models there was no risk analysis. So the main a plus point of this is like there's a risk analysis in every step it is been developed. What is this risk analysis here is you're trying to know, if you develop this project in the plan you have developed, what is the risk that is going to be included, either to change it or for the maintenance, whatever the matter may be for that. So how the risk is involved in this, it is also calculated. Okay, so next process is the process through steps. That is first thing in that is risk analysis. Then prototype 1 is developed. Next it comes to the develop and verify the next level product. In that, again, the concept of operations, how actually this part is operated, that thing comes. Then next is the plan next phases, that is a requirements plan, life cycle plan is done. Then it goes to again to the determine objectives, alternatives and constraints. Again risk analysis. Then prototype 2 is the iteration is done. Then emulations, whatever it's required is done. Then again software requirements and requirements validation is done. Development plan is done. Again next here the determine objectives, alternatives and constraints. Risk analysis calculated. Prototype 3 is developed. Models are built on that. Then software product design is made. Design validation and verification is done. Then integration and test plan is done. Again determine the objectives and alternatives constraints. Check the risk analysis. Then operational prototype is done. That is how actually your software would be working. Up to that step it will be developed. Then any benchmarks you need to add or keep in mind is done here. Detailed design is done. Coded unit testing is done. Integration testing is done. Acceptance testing is done. And lastly it is implemented. So what happens actually to this line, it's a commitment partition, that is for the review. Okay, and this is cumulative cost, how the cost increases. That is, once the one round completes this phase, the cost again increases, and this circle completes its one circle and cost this space, it again the cost increases. That is the thing. Okay, so this is how a spiral model looks like. Again, it's very important, you need to know this. So as I explained it, all the quadrants are given with their detailed explanation, like what are the objectives, alternatives and constraints it's having. In the next one, like evaluate alternatives and identify and resolve risk. What are the alternatives you have, how to identify the risk, all these things are done. Next is the develop next level product, where we design, review, develop, inspect and test. And the spiral quadrant in the next phase is to develop project plan, configuration management plan, test plan and installation plan. So then what are the strengths? Changing requirements can be accommodated. Whatever the requirements keep on changing, you can put into this. So when you have a very varying requirement changes in a software, you can use this model. Then allows extensive use of prototypes. So you can just develop a sample, send it to the customer, develop a sample and send it to the customer for review, and get it back and develop it in one more time. Okay, the actual process or the actual project can be done, uh, built, and requirements can be captured more accurately. That is, like you don't have to make a rough imagination, or you don't have to just have a rough idea of this. You can make it a very clear and a goal oriented ideas and plans, and based on that you can actually do this. And users see the system clearly, they understand, because every phase the part of the software is delivered to the customer, and they test it and they see how it is working, and then they say whether whatever the information it's given, or the working, is it right or not. Again it can be sent to the developer, and he makes the changes and sends it again. So the customer will be having a great idea how the project is working. It's not like one shot delivery, like once you give the requirements and you come up with the result. No, that is why the customer, whoever was who had asked for the project, or anybody stakeholder for that matter, he will know what the project is usually about, or how it is working, and what are the needs actually. By looking at it, if something gets into his mind, he can also build that and ask to build those things with the developers. So the development can be divided into smaller parts, and the risky parts can be developed earlier, which helps in better risk management. So then what are the weakness of this? It's very complex. You have seen the diagram itself, right? It's more complicated. But to solve projects on this model, the assessment expertise is required. Not somebody just can go and find the risk, what is the risk involved. So there needs to be an expert. Spiral may continue indefinitely. See, in that figure we have stopped it somewhere, but it is not the case. If you want to add one more force, you can again extend that spiral. Okay. Then developers must be reassigned during non-development phase activities. That is, some of the quadrants are empty, that. So in during that time the developers have to be given with the other development phases. Okay. Then management of this is very complex, because since the project itself, model itself is a kind of complicated, so managing those complicated models is also difficult. So when the project ends, if you ask, nobody may know the answer, because you can develop it infinitely or indefinitely, and it's not suitable for smaller low risk project. Like you're doing it, you're having the risk analysis because you want to find out what are the risks involved. Okay, if the risk is very low and it is not going to affect anything, there is no point of doing the risk analysis. So only when there is a risk involved, a very high amount of risk involved in the project, this is done. And it could be expensive for small projects, only for the bigger projects we do this. So if these are the things, then when we are using the spiral model, when creation of a prototype is appropriate, you need to have a prototype, and based on that prototype you are actually developing a whole software. In that case you can use the spiral model. And when cost and risk evaluation is important, because some of the huge projects, if you are working in, if you don't calculate the risk, then there is no point of developing that software itself. That is why. And cost is also an important factor. So when cost and risk evaluation is important, you need to use this model. Then from medium to high risk projects, there should be a risk factor, there is no point in developing this spiral model. So if it's a risk is about medium to high risk, you can use this model. And where the long term project commitment is risky, because as I told you, in the long run the technology gets obsolete, so that is the important thing. So that is where risk analysis is done. That is, potential changes or economic priorities are to be seen or kept in check. Only in that cases we use this model. And users are unsure of their needs, like they may have some requirements at the in the in between the development of the project. In that case also you can use. Then requirements to tell them the requirements is also difficult or complex. In that case also we use the spiral model. And significant changes are expected. Okay, that is like you need to do research, and then you have to come up with the plan for the software. In that case, you are using this spiral model. Thank you.